So we have the faces. We have now what we are doing here is we're creating an empty array using this type that is a very complicated type from what we were able to gather. It creates, basically, given the number of faces, in this case we have 12, it's going to create a NumPy array with 12 elements of this type, D type. And now, what's it doing? It's setting the vectors. So I is the number of faces for each face, right? Then it's going and retrieving that from the list of vertices, right? So F is the faces themselves. So it's going to get, as we discussed, each number here is basically referring to a vertex. So it's basically getting all the vertices and putting that into a vector for the cube. So enumerate creates is basically a way to iterate through the list of faces. And the nice thing about enumerate is that it gives you like an index that you can use. So we are enumerating this, which means we're going from 0 to 11. So we start with 0 here, and then once we are with this face, we go and get the vertices for this face. So each vector has 3 vertices, and that's what we're doing here. We're storing that for each face, right? And then the last statement here creates the cube and saves it as an STL file. And that's it. Code done. Okay, so let's see what we can do after this. So, simple example. How to do the cube. Okay. Okay, so this is done. So next example, see if there's anything useful. So in the library itself, you'll see more examples that right now they are not very meaningful, like combining multiple STL files. If you have more than one object, you can combine it into one. Let's say you have different artifacts of a 3D object. You can put them together using this code, but I don't think we're going to use this for now. I wanted to do something a bit more interesting, and I may end up regretting it, but how about we try and do something, take a picture and see if we can create like a version of that picture as a lithophane. And if you don't know what a lithophane is, it's basically like a piece of plastic that has different widths, and depending on the different widths that you have, it will basically let light go through, more or less. So you can see here you can see this is a lithophane. It's plastic, but I have one here. So this is a lithophane. It's like a moon, a version of the moon, which basically, if you put light shining through here, it basically shows a different. It's the surface of the moon. So this is a lithophane. I want to do a simple lithophane today. I'm not really trying to do something too complicated, although it's not the easiest thing in the world. Let's see. So if I was going to create a lithophane, I would have to use some kind of image as the basis. So I'm going to put some code here. Read image from file. Now I have to find an image. So which image should I use? Okay, I'm going to use my background. So I'm going to upload a file here on the left hand side. This one. So this is going to be the image I'm going to play with. So what I'm supposed to do basically is to create, to read an image from a file, convert the image from color to grayscale, then take the pixel intensity in grayscale, which goes from 0 to 255, and I would be using that to create a 3D object using the thickness of each coordinate in the picture. Of course, I need to downsample the picture to something more manageable, because otherwise the 3D model itself could be huge. So I'm going to use a library called Pale. And if we go and look at the Pale library, it gives you examples here on how you can create an image and show it. Okay, so I'm going to first do that. Need to copy the path. Yeah, and then so I'm going to use Matplotlib to print the image so we can see the image itself. Okay, so we can see here the image. Okay. So we can see the image and display it. So let's see how to convert this to grayscale. So let's see how to convert something to grayscale. There is different ways in. Okay, as you can imagine, right? An image has its 3 different colors at least: red, green, and blue. And then if we're converting this to grayscale, then we have to basically take the pixel intensity of each color, somehow average it together, and get only one. So you could maybe take the 3 pixel intensities and divide it by 3, right? There's different algorithms on how to convert an image to grayscale, and it's out of the scope of what we're doing here. I'm just going to use whatever is easiest. So we can see here an example of converting an image to RGB, which is not what we want. We want grayscale. It's much more complicated than I wanted it. Okay, this one is complicated, basically where we are. As I mentioned earlier, you can average the values of the different colors, but this one is actually using a formula, so it's taking 29% of the red, 58% of the green, and 11% of the blue, and then gives you the new color, the grayscale intensity. But honestly, I don't care. For now. Maybe later. So we can open the same image. necessarily want to overwrite anything I've done before, so I'm just going to... Right, so it's in grayscale. So in grayscale, I basically have, well, a matrix, and then each element in a matrix is a light intensity. So how do we go from a cube to a laser beam? Maybe that's a big jump, but... So if I wanted to draw, I mean, we know how to draw this surface, right? This is going to be almost like a cube, but the difference is each face. In fact, we're not going to have a cube itself, but it's just going to have one face, one single surface, and it's going to have different heights. So if I just wanted to draw this, yeah, maybe we start with this. We're just going to have one face and with lots of triangles. I'm going to copy this code. So I'm kind of making things as I go along, yeah? So I haven't really... Okay, so I'm probably going to struggle, and you'll see me struggling and trying to resolve some problems. Hopefully I have time for this. So first thing I want to do is just simplify this. Instead of having a cube, I'm just going to have one single surface. So we could define this vertex, this vertex, this vertex, and this vertex. 4 vertices. 1, 2, 3, 4. So let's delete everything else. Okay, 1, 2, 3, 4. We only need one face, so I'm going to just have 1, 0, 3, 1. I'll need 2 faces. So, since I want to be different, I'm going to define my first triangle. It's going to be these 3 points. 0, 1, 2. Right, that's my first triangle. Then my second triangle is going to be -1, 1, -1. This is the 1. Then this one is 1, -1, -1. Okay, the second one, which is 1. The final vertex is this one. -1, -1, -1. Should be on this. No longer is going to be a cube. It's going to be just a surface with 2 triangles. Okay, I shouldn't have called. I'm going to call it surface. And you'll see it here. I'm going to download it. And I'm going to leave object mode. With edit mode, I'm going to So I'm importing STL. Let's see. I might have made a mistake, but I'm going to do it. Okay, so I have, hang on. I've created the wrong triangles, okay. Creates a funny shape. We see, because I picked this triangle and I picked this triangle. In fact, I should have picked this triangle and then this triangle. Right, so this is fun, right? So, object mode. So, this is -1. So 1 -1. Which one have we picked right? I think this one was right. I just had to pick. Basically, the second one is the one that I've defined this one. So I'm going to redo the first one. So -1 -1 -1, which is the second vertex, which is index 1. So right here. good start from nothing, otherwise I'll get lost again. So yeah, now I pick this one. 1, 1, minus 1. It's 0, 1, 2, 2, and then the last vertex is going to be this one. Minus 1, 1, minus 1. And that's going to be minus 1, 1, minus 1, 3. Okay, let's try it. Okay, so now it looks good, right? So this is a surface. It looks like a square, but when you look into the vertices, we have like 2 triangles. I have an image of what resolution? Let's see. I'm working everything out. Okay, so this image has 0 to 3000 and then 0 to 4000. If I wanted to be very very detailed in my lithograph, I would create an impossibly large mesh of 3000 times 4000 vertices. Of course, I'll have to simplify, but right now let's assume I don't want to complicate things further, because at some point, and this is where things get more complicated, but you start always simple. I'm just going to create like impossibly large mesh for the time being, and you'll see actually that I might even struggle to generate the mesh. Okay, so I want to change the pixel intensity of each coordinate in the lithoplane, right? So I'm not going to be able to do that with this shape here. I mean, if you look at it in detail, right, I could change the height of this vertex, but then all the vertices inside here, there's no vertices basically. All the points inside this surface, I couldn't change it at all. So it's not feasible. So I need to divide this square in many more triangles than what I have right now. Okay? But of course, I'm not going to be able to use this system here where I'm actually just enumerating all the different faces. So what I'm going to do, I'm going to create a list of vertices, for example, from here to here, then another list of vertices from here to here, and then I'm going to create some kind of function to merge, to create the faces automatically, and then I'll have lots of triangles. So right now, what I want to do first, before I worry about heights and I'm not even going to think about the lithoplane just yet. I just want to divide these into many triangles and see how we manage to do it. I'm sure the way I'm going to do it is probably not the smartest way. Maybe later I can optimize if it makes sense, but right now I'm just concerned getting it done. And there should always be our concern. Don't necessarily try to be like the smartest. Don't come up with the smartest solution. Come with a solution that works first, and then you can work out from there. So the way we created a NumPy right here, we just provided a list of vertices. So we enumerated all the vertices, which we can't really do properly like that now. Okay, now we're going to complicate, right? So I've created a 2D surface with 2 triangles. Now I'm going to create a surface, let's say I'm going to just let's call it 1000 times 5000, okay? It doesn't matter width and triangles. I don't even know how many triangles I'm going to use, but we'll basically define that a little bit better. So, NumPy happened here. So how do we create an array of 1,000 times 5,000? Let's go and look at the documentation. NumPy, I'm going to pretend I didn't know. Right, okay. NumPy array. So we've seen how to create a NumPy array just by giving it a list. You can also force it to have n dimensions, even though you pass in a single dimension list, or you can have something even more complex, like a complex number, or something similar to the notation we saw earlier in the video. I don't like these examples. I just want to pass in a length. So the NP0 is probably going to be our NP0 is going to be our friend here. NumPy.zeros. So if I want to create an array with 5 elements, this is the way to do it. It creates it's basically empty with a list of zeros. So you see here we're creating an array with number of rows 2, number of columns 1. So number of rows in our case is going to be like the width. I'm just going to put it here, equal to 1,000. Sorry, the height, number of rows, and number of columns equal to 5,000. So just to visualize that, right? This is columns, right? So you have columns here, 1, 2, 3, 4, 5, and so on. And this is the rows. So we'll have a list of vertices in each row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to connect each row to the next row. That's going to be fun. But for now, let's just create an array of 1,000 times 5,000. I'm not quite there yet. Can you see what I've just done? So it has a bunch of zeros now. So 5,000 on each row. So I have 1,000 rows. I'm going to want to define a list of vertices, right? Each vertex has 3 coordinates, right? So for each element here, I need to specify 3 numbers. So I'm going to have to pass in 3. So this becomes a little bit more complicated, right? So, okay. So I'm just going to use a piece of paper and try to visualize this for you. Okay. The first row has 5,000 columns, 5,000 cells, right? And each cell has 3 numbers. This is what we've just done. Okay, so with this array itself, I can fill it in with coordinates. And let's think this through, okay? So I'm going to simplify everything at the beginning. I don't care about whether my mesh is going to be absolutely, it's going to be massive, to be honest, right? But to make it easy, I'm going to make z equal to 0 to simplify this for us. We don't care about, you know, we want to have as less transformations as possible. So I'm going to make this 0 every time. So you see here, so 0. So we know that for each vertex that we're going to create in our surface, z is always going to be 0. So we only have to play with x and y. So I'm going to create the first row, and I'm going to start with x equal to 0, and I'm going to end with x equal to number of rows, sorry, number of columns, which is, in this case, is going to be 5,000, right? it. So for x in range of 0 to number of columns, the brackets are optional. And then for y in range of 0 to number of rows. Okay, so I'm basically filling in all the coordinates for all the vertices in null surface, right? We already said z equal to 0 every time, so our coordinates are going to be x, y, and z. So vertices, maybe x and y is not a good name, but so I have to start with y first, then x, right? Right now it's simple because z equal to 0, so we just basically change the name of the array to vertices. Right. Right, it seems like I had misspelled vertices, and now I've corrected the misspelling in this variable and it's working. So now I'm able to create a list of vertices in a NumPy array with 2 dimensions. Each cell in the array has a 3-dimensional coordinate. Z is always set to 0, so we only vary x and y. And if I run that, I need to import it again. I had to restart the container. So I'm creating this massive NumPy array, which is 1,000 times 5,000. So how many cells in that? So about 5 million cells. So that's a lot of cells, right? We're talking about, this is one cell. And we just created an array with 5 million cells. And these 5 million cells, we're only talking about a 2-dimensional array. So for sure, before I import this to Blender, I will want to reduce the size of this. But I'm just starting this way so we can see how it works. But let's keep it simple for now, right? No point to try and resize anything right now until we figure out how to do the main algorithm first. It's a trial and error with lots of errors in a way, but you know, that's life. So I've created now a list of vertices, and what I really need to do, going back to this code, right? I'm debugging this code, this example here. So it's actually, I don't know if I really need to follow this step here, where I create a list of faces, right? Because this list of faces is using the index of each coordinate, of each vertex. So you see 0 is vertex 0 here, 3 is vertex 3, 0, 1, 2, right? So we're doing all of that, but then later on, we're converting everything, we're actually fetching the vertices straight anyway. In this section of the code, it's actually trying to create the vectors. So it's creating the vector property inside the cube, inside the mesh. So it's basically deconstructing it anyway. So my thinking is, do I really need to bother and create this? Why can't I just build the vectors straight away? And let's see what these vectors are for, because I don't have that in my mind. So NumPy STL. Okay. The documentation is always important. See if I can find anything so that. This is the mesh we want, right? So I think this is the example we saw before. This is actually an example where we're actually skipping creating the faces and we go straight to vectors. So I think this is like 0, 1, 1. Just try to see if Google gives me more information. doesn't have much information about this, but okay. So vectors is basically going through each phase, and then for each phase it goes like, it creates a range, like when a range of 3 is 0, 1, 2, right? So it will do j equal to 0. So this is I, basically is the index of the phase. So phase, for example, 0, and then index, and then coordinates 0. Then it passes in f of j, which is going to be within the phase itself. It's going to be the first number. So basically this is going to be, it's going to be fetching the vertex within this list of, for example, of whatever index is. Like, let's start this one as an example. So a vertex 0, so -1, -1, -1. It's actually a strange notation because this is almost like a slicing notation. I have to review my knowledge about slicing.